Okay, guys, so now we're gonna talk about quadratic equations, right? Well, let me not say equations because we're talking about patterns here. We're talking about sequences. So this is quadratic sequence. And I want to say there's nothing. Remember, you guys started learning about quadratic sequence in grade 11. And I just want to say there's nothing new that you learned, that you're going to learn in grade 12 that you haven't learned in, when? In grade 11. That's what I want to say. Yeah. So I'm just gonna show you something, and yeah, I'm just gonna show you something so cool, right? So we're gonna take this, yeah, and we're going to substitute the value of n, and let's see what we get. The first one, we're gonna have a. Here we're gonna have a plus b plus c. That's the first one, yeah. Cool. And then the second one here, we're gonna have, oh, it's gonna be 2, which is 4. So 4a plus 2b plus c. All right, let me substitute the third one. We're gonna have 3 squared, that is 9. So you have 9a plus 3b plus c. All right, something cool, something cool. And now we're gonna find the difference between the consecutive terms. So we have 9a plus 3b plus c minus 4a plus 2b plus c. So c minus c, that is 0. Here we have just b, plus here we're gonna have 5a, right? So I'll put it here. We have 5a plus b. All right. Find the difference there. You have 4a plus 2b plus c. You have a plus b plus c, and we are subtracting. You're gonna have 0 plus b plus 3a, right? So you have 3a plus b. Okay. So then I want us to focus here now. Yes, let's focus on this 2. So you have 5a plus b. We are subtracting 3a plus b. All right, so b minus b, you got 0. 5 minus 3, you get 2a, right? Yeah, so you end up with 2a, right? And then with what I have done, I'm gonna say, okay, then let's focus here, right? Maybe let me put it in a nice rectangular something. Yeah, so let's focus on this, ne? Yeah, this is what I want us to focus on, because I'm sure you recognize these values, ne? These are the values that we use, right, whenever we trying to find the equation, right, of a quadratic sequence, right? Cool. So yeah, let's use these examples we have to cook something. So something about the quadratic pattern is that the first thing first, always the first thing is you find the first difference, right? So you find the first difference, and then after finding the first difference, you're gonna find the where we have the value here and here. So you're gonna find the second difference, which we are expecting the second difference to be the same through all out. All right, so let's do the math here. We have 7 minus 2, which is 5. All right, so we have 5, and 14 minus 7, that is 7. 23 minus 14, that is probably 9. And then here it's 2, right? So this is also one of the easiest way to spot a quadratic sequence. You would see that first difference not the same, and first difference is an arithmetic sequence. Second difference, the numbers are all the same, so we have a common difference, right? So now how we end up finding the general term, we go here. second difference equals to 2a, right? Therefore 2 equals to 2a, and then a equals to 1, right? After there we go here, ne? Then we say 5 equals to 3a plus b. Let's see it. 3a plus b, yes sir. So you have 5 equals to 3 into 1 plus b. 5 minus 3, b. Therefore b is equals to 2, right? And then we go again and say a plus b plus c, right, equals to a plus b plus c equals to 2, right? So a is 1, b is 2, c, right, 2. So this is c plus 3, the c 2 minus 3 equals to minus 1. Right, so now that you found it, you then say therefore Tn equals to n squared, because remember a is 1, so you have n squared plus 2b minus 1. Right, we can give it a test, so you have n squared plus 2n minus 1. If we substitute the value 3, we should get something like 14. And yes, we did. All right, let's see for 4. We must get 23 for 4, and yes, we are getting 23. So you see, that's just how easy it is. And let's test it. Let's give it a test with this example. Almost. Yeah, no. Let me do this. Let me do this. I want you guys to see something. Okay, because I was gonna say like these patterns, they are the same, because you see you have 2, you have 7, you have 14, right? You can already tell here it's gonna be, right, but something is gonna be different, right? So in that case, perhaps let me not remove the general formula for the first one, and we're just gonna compare it to the second one, but they will be different. And the reason they will be different is because their first terms are not the same. That's the only thing that's going to make the general formula different. So first difference, we have 7, we have 5, and we have 2 minus 1, that is 3, right? And then you have 2, of course. So then you have 2a equals to 2, therefore a equals to 1, right? And then you have 3a plus b equals to 3. 3 into 1 plus b equals to 3, and therefore b equals to 0, right? And then you already see that b is already 0 here. And then you have a plus b plus c equals to minus 1, right? So 1 plus 0 plus c equals minus 1, right? Therefore c equals to minus 1 minus 1, which is minus 2, right? And yes, it's true, minus 2 plus 1 is minus 1, and therefore you have Tn being what? Being being n squared, because a is 1, and then 0, we don't have it. B is 0, so we want to have b, and then c is minus 2, right? So basically you have minus 2. Yeah, you have something like this. And let's see, this is the fourth term, right? 1, 2, 3, 4. We're getting 14 for the fourth term. Let's see, for the first one, we're getting minus 1. For the third one, we're getting minus 7. Do you understand? So guys, it works. Let's see. We have the third problem there. Let's do it. Oh, come on. So, yeah. Okay, okay. Nice one. Cool, 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 cool. So the first term of a quadratic sequence is 4. Right. The third term is 34. So I'll have a and then the third term is 34. And the common difference in the second difference is 10. Right. So here I'll just say x. Determine the first 6 terms in the oh my god. This is beautiful. This is beautiful. This is just pure beauty. So this is what we know so far. We don't know the second term because they said we have x. They didn't say anything about it, in fact, but we know about the common difference in the second difference. I mean, the only place where they have a common difference is in the second difference. There's no way. If we have the common difference as the first difference, we are talking about arithmetic, right? Just know it. So now, with what we have here, I'm gonna add something a little bit extra. Yeah, I'm gonna add something a little bit extra, but I want to move it this side. Move it this side, and here I'm gonna put on these values here. So I know this value, the value here, right? It's 34 minus x. So 34 minus x, right? And I know the value that is going to come here. It's going to be x minus 4, right? So I have x minus 4 equals 10, right? No. So yeah. No. That was completely wrong. What 10 is going to be is this gentleman minus this gentleman. So first bracket 34 minus x close bracket minus open bracket x minus 4 close bracket. Yeah, equals to 10. So now 34 minus x minus x minus that's so plus 4 equals 10. Here I'm gonna have 38, right? That is 28, and therefore x is going to be I don't know, my mind just got stuck. 10, 10, 14, yeah. Away. Right. So now I know what x is, right? I'm just gonna substitute it. Right. So here I have 14. Yeah? And then here, therefore I have 34 minus 14, 20. I have 20 here. I'm expecting a 10 here. Right. So 14 minus 4, it is a 10. Right. Cool stuff. So now with what I've done, I can just find the general formula. First, 2a equals to 10, right? And therefore a equals to 5. Then 3a plus b equals to 10. Now it's this 10, right? And therefore 3 times 5 plus b equals to 10. So b is going to be 10 minus 15, which is minus 5. A plus b plus c equals to 4, right? Because the first term is 4, so that is 5 minus 5 plus c, right? and therefore c equals to 4. Therefore Tn equals to 5n squared minus 5b plus 4. Right, let's just give it a test with the three numbers we have. 5x squared minus 5x plus 4, we put 1, we are expecting 4, we get 4. Let's put 2, we are expecting how much for 2? 14, eh? And we are getting 14. How about 3? For 3 we are expecting 34, right? Yes, we're getting 34. So therefore, to get the 6 first terms in the sequence, you're just gonna substitute for n. You're gonna substitute n equals to 4, n equals to 5, n equals to 6, right? Then with that you'd have yeah, the first 6 terms, because it's term 1, 2, 3, then 4, 5, 6, right? You just use this equation, substitute, and then you will have your answers. Okay, so that's the end of quadratic sequences. Yeah, I will see you in the next video, guys.